Hey everyone, we're just going to give it a couple seconds here to let people log in, and then we'll get started. All right, good morning, good afternoon, wherever you're joining us from today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner, Viscosity North America. We've got Oracle ACE Director and Viscosity CIO presenting for us today, Rich Niemiec. Yes, this is a live webinar, so feel free to submit questions in the Q&A field, and Rich will get to your questions as he can. This is also recorded, so probably sometime tomorrow, you should have a link from either NYOUG or Viscosity and access to the slide deck as well. So be on the lookout for that. All right, my name is Monica Lee. I'm the marketing director here at Viscosity, and co-hosting with me today are NYOUG board members Coleman Leviter and Rob Edwards. Rob is going to tell us a little bit about NYOUG, and then I'll quickly introduce you to Viscosity, and then we'll get started.
Thank you, Monica. I'm treasurer of the New York Oracle Users Group. NYOUG was founded in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. We can be found on Twitter, Meetup, LinkedIn, Facebook, and our website, nyoug.org. We'd like to thank Viscosity North America and Monica for co-hosting these webinars with us for the last 3 years. Monica?
Thank you so much, Rob. I'm going to try to make this quick because I know Rich has a lot of great content to share with you guys. So on this page, I'm just going to show you a very quick overview on this one slide of Viscosity. We are built upon these 3 main pillars: data, apps, and infrastructure, cloud. And across the bottom, you'll see services that we offer for all 3 pillars. So if this is something that you guys are working on and we can help with any of your pain points across any of these pillars, please let me know. I'd love to get you in touch with my team, see how we can help make your job easier. All right, on this slide, you'll see some of my colleagues and also speakers, writers. They're also our consultants for our clients. These guys represent the Oracle ACE program, or some of the Oracle ACE program, I should say, across the different tiers, from ACE directors to, actually we have ACE Pro, ACE Alumni, and ACE Director. No ACE Associates anymore, but hopefully we can get more of our teammates out there. If you're not familiar with the ACE program, I highly recommend looking into it. If you're someone who is heavily involved in the Oracle community in any capacity, you can also apply to become an Oracle ACE. But if not, it's also a great place to just find people who provide consistent, great content on Oracle technologies. They're either presenting live, in person, they're writing books, blogs, you name it. And this is across the globe. So very proud of these colleagues right here. And as the marketing wing of Viscosity, I get to work with them a lot, which is very nice. All right. On this slide, I'm just going to point out Oracle License Management. This is one of the things I like to remind people of the most, just because it's honestly, I think, one of the biggest headaches. I don't think I have anyone from Oracle on here right now, but it is sometimes a big pain for our clients. And since partners like Viscosity work hand in hand with Oracle sales and Oracle product management, it is a faster, more easy way for you guys to make sure you're only investing in what you need. And then we also want to make sure you're taking advantage of the things that you purchase. So put that on a partner like Viscosity. I highly recommend it. It will save you a lot of time. Okay, a couple books to highlight. The newest ones are Oracle Database Performance Tuning, Upgrading Oracle Databases, and Oracle on Docker. Rich and myself will be at Oracle Cloud World this year, and I'm currently in the works of getting some book signings together and hopefully some things on the exhibit floor for you guys to come visit Viscosity, whether they're guests doing book signings or little 15-minute talks. We'll also hopefully have some sessions there. Okay. And then orapub.com is where we host all of our recordings and slide decks. NYOUG.org will also have them as well. I always like to recommend people sign up for a free membership here at Orapub because you have access to pretty much every recording we have done for free webinars. There's also paid training you can have there. If you're a paid tier member, you get discounts on those. And if not, you can check out the full price there and hopefully your management reimburses you for it. A lot of our live training is about 3 days long, half-day trainings. They're great. I highly recommend those as well. But you can go check that out all at orapub.com. And with that, I think I'm going to turn it back over to Rob to introduce Rich real quick to us. And Rich, feel free to get your slides up.
Okay, thank you, Monica. Rich Niemiec is the current Chief Innovation Officer of Viscosity North America. Rich is an Oracle ACE Director, a world-renowned IT expert, and was the co-founder and the CEO of Tusk, a Chicago-based systems integrator of Oracle-based business solutions started in 1988. Rich has served as president of Volta Tusk and Volta EICT. Rich, it's all yours.
All right. Well, thanks for having me here. I hope you could see my screen here. I just want to say, first of all, thanks for everyone who has worked with us in the past, and especially those at the New York Oracle User Group. You guys have some great leaders there. This is going to be a talk not to learn about machine learning, although it'll have machine learning, not to learn about transformers or BART or ChatGPT, but it'll have a little of that in there, mostly FYI. It's going to be to give you exposure, to tell you where you are in history. How fast are things moving right now? Well, in November 2022, ChatGPT came out. How fast have we seen ChatGPT grow now? ChatGPT 4 is out. How fast are things moving to show you that you have truly crossed into the Twilight Zone? That is what this talk is about, and you really are there, whether you realized it or not. I want to thank Monica for all she does for these sessions as well. You could see some of the things we're going to look at, but it's going to be to give you exposure. It's not to learn everything. Don't try to learn everything, but you can get this talk from Viscosity and they'll get it to you. But what do we want to do? We want to win. I take that and I say that stands for what's important now. What's important now for you to focus on? Well, you've entered the Twilight Zone. It's a Twilight Zone you should see now. A lot of data has been coming at us for the last 20 years. And then we just started getting into more machine learning in Oracle, although I'll look at other ones. How fast are we going to move into where machine learning replaces that robot's mind or that future tech, or are there already robots? And then we'll look a little bit ahead at how did ChatGPT come from? Came from a paper from Google, and we'll look at what's after ChatGPT, foundation models. But in my opinion, you've really already crossed into the Twilight Zone. You may not know it yet. So in case you didn't know it, you have crossed into a different place. You may not know it. You may not have noticed it. But the year is 2023. Our hero in this episode is your typical tech worker. They're overworked. They're often underappreciated, especially those DBAs. They're overwhelmed by the increasing pace of technology. Now, with the addition of machine learning and just recently ChatGPT, their last thread of sanity is about to snap them, thrusting them headfirst into the Twilight Zone. You thought it couldn't happen. You saw the Twilight Zone. Where is everybody? There was nobody else on earth but one guy. And then COVID came. Streets of New York, Times Square, empty. Streets of Chicago, empty. The theater's mostly empty. Just to let you know, NASA actually tests that. This set was used in Back to the Future, in case you don't know. People couldn't gamble on anything because there was no sports. They started gambling on COVID statistics, political elections, the weather, current events. Very similar to the fever. They couldn't stop. But we're really entering another place where, very similar to the brain center at Whipple's, where he was reducing a lot of employees with robotics. Robots now have facial expressions. They can move. They can think. Somewhat automated. Sophia robot, we'll talk about a little bit later, but Pepper the robot I could integrate with Oracle. We're moving to a new place. Not where we've been before, where robotics and automation is going to have a heavy impact to certain jobs. But it's also going to create ones where you work alongside a robot. I think the most valuable people, and when I studied some machine learning at MIT, just to kind of, I saw it coming, I don't know, 5-7 years ago. Can't remember anymore. It's gone so fast. But they talked about how we're going to move to this era where the people that work alongside those machines are going to be the most valuable people. And you can see where the lower income jobs are the ones that are going to be hit the most. And certain countries will be hit harder. But you already see these robots on college campuses delivering food. Some people are a little worried about them, but do we really need people pin setting or being telephone operators or ice cutters or lamp lighters, typesetters? Some jobs are just obsolete. People are not, though. The DBA, very important. It's not obsolete. It's a job that's going to be growing fast, and we'll see why in just a minute. It's the number 8 emerging job, data engineer, works with the analytics team. So you got to work with the data scientists. They'll pay you, I don't know, 50% more. You have to make sure you work half as long, be at the meetup at 4 p.m. on a Friday. But the DBA is the most important part of that machine learning process. If you look at this, the machine learning part is 20%, and the data side of things and some of the developer skills and DBA skills are the 80% of the projects. And lo and behold, 80% of the projects are currently failing in machine learning. Well, first of all, what do you need with machine learning? We need a lot of data, the 5 V's. It's very big, but it has different values. Boy, a DBA or developer could come in, could be very helpful. Different varieties of data. Wow. Relational database could be very happy. Velocity. Well, that would be nice to have JSON for that speed. Veracity, different truths of data even. How are you handling that? How are you handling it? Multiple databases? Well, right now, Oracle has all those different databases in one database. Also puts things in memory at the data level, at the record level, or at the column level for analytics. And you can also look at both of those in the later version in 23C. But you can look at files, spatial, graph, key value, JSON, relational. One database. Same security, same skills. Wouldn't that be helpful? It's already there. You just need to be a data administrator if you're a DBA to get into the world where you handle more of this data. Oh, that was good. I just hit the end button. So if you record on the recording, I don't know. I guess I could say my cat hit the screen. My dog hit the screen. I don't know. It wasn't that. Let's see. Did I get to the right slide? Almost. Sorry about that. But data is the new oil. There was a Twilight Zone where this guy would give you what you need. Oh, you need this pair of scissors because your scarf that you're wearing, it's going to catch in the elevator. You're going to have to cut it free. What is analytics? It's what you need. Used to be what happened, then why did it happen? Then what's happening now? What's going to happen? And then prescriptive analytics. Can you make a better future? Can you prescribe it for me? Think of the hitchhiker. This is similar. Maybe we're in a futuristic. Let's put it 10 years into the future. I don't think it's more than that, but we'll be in a conference room. We'll be doing a presentation like this, and then in is going to walk the EMTs, and they're going to say yes, and we're just all going to look back and go, oh, I wonder who it is. It's going to have all these devices and all these connections. Going to tell somebody in the room is about to have a heart attack. And we're going to get there just the moment before that's going to happen. And we're going to prevent that from happening. We're very close to that now. I don't think it'll even take 10 years. But a robot doesn't necessarily look like a robot. Keep that in mind. They work 24/7. You don't want to compete with them. You want them to augment you. That's the key. But Alexa, Siri, they're robots. Autonomous database is a robot that assists you and helps you with your job. That database, self-managing, self-securing, tuning, recover, puts the patch on before you even know that you need it. Does it change your job? Yes, makes you more valuable because now you can manage more databases. How hard is it to build? If you've never done it, it takes 2 minutes to provision automatic transaction processing. If you're doing more transaction processing, first Q4, when this came out, it was 70% growth. You can also manage scaling, and it takes all of, I'd like to move to 2 CPUs, 4, whatever you want to move to, 64. And in 50 seconds, I'm now running 2 CPUs instead of 1. And it's available with 2 now. How about stop the database? Click stop. Are you sure? It goes from yellow, stopped. I would have thought red, but red's actually something more serious. ADW, you do more of analytics. You want to do columnar things into memory. ADW up in 1 minute and 20 seconds. I built a database. There's all kinds of things, whether it's data warehouse, JSON, transaction processing. There's also Apex there. I've tried them all. This is my own cloud. You could see some of the things. There's autonomous JSON, autonomous Apex. Make sure you shut some of them down if you're not using them. So you're not paying for that. How long does it take to start it? 30 seconds. It's up. So, and then I can go into database actions, go into machine learning, build some notebooks, look at some examples, or just get some information, which I click just to see to get started. And it gives me some quick start tutorials. I could run SQL, select star from tab, could do that since version 4. Create table, just like you do now. I'll click the pie chart and see that. What do I have here? I have what's called a notebook, a series of SQL or PL SQL or Python or R statements that I have. Talk about that in a little bit, but just briefly, just to give you exposure. Again, just to give you exposure. Where has Larry put machine learning? In their own applications, software as a service, embedded. Currently, you're running something like manufacturing. It gives you machine learning to tell you, oh, you're going to have some manufacturing issues right now. And these are the ones we see. Oh, you're not using the right amount of some additive. The temperature in the room's not correct. We've also put it in an autonomous database. We'll see that in a second. They also bought a company called datascience.com and they put it there. They've also put it in the Oracle Analytics Cloud. The first piece to know, though, that came out was machine learning in general. Now look at machine learning in this way. The part on the left I built, Oracle built all the functions they do on the right here. Just kind of a nice diagram to find on page 356 or so. But first, what's the business problem I'm trying to solve? Oh, I want to separate my good and bad and customers and the ones maybe I don't know. Maybe I'm classifying. Oh, I want to find fraud. Oh, maybe I'm looking for anomaly detection. But after I find that business problem, what's that function here on the right that I want to do? Then what algorithm do I use? Well, there's multiple classification algorithms. Depending on the version, there's more, but at least 7. I'm going to train the model using an algorithm, teach it with some of my data. I know what the answer should be when I test it with the other 40 to see if it worked right, and then compare those algorithms. So that's all it's doing very quickly. What's the problem? The better you define it, the better the answer. I'm separating good and bad customers. I'm clustering data into age groups, whatever it is. Here's an example of how easy it is. You're not here to learn this. It's just how easy it is. I have this table. I'm going to drop the model. This is so I can run this over and over till I get it right, recreate the table. Then I insert and give it an algorithm name. And I'm doing, in this case, attribute importance. So the mining function that we saw in the last one is, I want to know what attributes make up my best customer. Okay. What are the attributes in this case? What are the attributes of people that buy insurance? Oh, they have a lot of bank funds. That's the number one attribute. Then once I have those attributes, and I say by customer, show me, who's buying insurance, but in this case, they're looking at attributes itself. Then I'm going to take those on the next slide. Now I'm going to classify some data I have, or maybe it's the person at the window right now, and I want to see if they can afford it. And I'm going to say, are they going to buy insurance? This time I'm classifying whether they're going to buy it, yes or no. And I want to know yes, but I'm going to use their bank funds and some other things to predict exactly what it is. So SQL, PL SQL, it's not very long to learn. Now there's a lot of things you do, creating a model. I give it a name, I give it a query, table I'm going after. There's columns by customer. I want to find out they're going to buy insurance. There's a few things, how many clusters I want, things like that. But I create the model, and create model 2 just is so you don't have to recreate some of the transient objects. I have some information here, the names of the different algorithms. I'm going to show you many of those, if not all of them. And then Oracle uses a very specific name. So that's good to know. And there's also other settings. You can see here on the right, if I'm using a clustering algorithm, it wants to know how many clusters. If I'm doing anomaly detection, what is the other piece that I think is very important is the math side of it. Somebody built the math, 50, 80 years ago to build a circle around this, and anything that falls outside, that's an anomaly. So nobody has to write that now. It's already done. Here's good and bad customers. The red line is how I want to separate them. Now, when I go to autonomous transaction processing or data warehouse, wherever you want to do this, database actions, I go into machine learning, pull this up. I'm going to go into notebooks. But before I do that, I want to show you just the examples they have. They have them in R. They have them in Python, many different examples. They have it in SQL, many different examples. Then when I go into a notebook, what am I building? I'm building what I did before when I showed you those text examples of the customer buying insurance. Give it a name. It's classifying data. It's doing by customer ID. Is it null? That means, is it anomaly? And it's using an algorithm called support vector machine to do this. The rest of it is SQL. What's the probability that they're anomalous? Calling this algorithm that I just created. Create a model called Customer 360. Then I'm going to use that model and predict if they're anomalous. Now I could do that by whatever SQL I want, by name, by address, etc. I can go further and say, give me the top 15 anomalous. Could zoom in here for a second. Now I'm going to look at the attributes that are making them anomalous. Why are these customers anomalous? So the short answer is it's not difficult. Here's another one, just shows a decision tree. I want to see if somebody's going to buy insurance or not. You can see a decision tree now. I'm classifying on whether they're going to buy this logoed credit card. You know, the guy in New York, he's not buying it, but the guy in Chicago is. Wonder why. There's all these different examples out there. So from a machine learning standpoint, how long will it take you to learn it? Not really that hard. You're not here to learn it, but I think if you want to get great at machine learning, like the game of pool, the guy says it takes 4 things: talent. You're on this call, you have the talent. Luck. You were lucky enough to have free time today, so you're going to learn some things and be exposed to some things. And you've got to take the work and start to apply it to your company. And you got to have the nerve to tell people that you need to do it at your company. So what are some of the things you can do? And I'm not going to go into detail at all, just to show you a feeling of what you could do. I could classify good and bad customers. This is classifying maybe spam. This is numerically looking at what happened in the past. So it looks at old spam. It kind of sees if it's new. Or I could do logistic regression. In this case, I'm using it as a classifier though. And it chooses between 2 things. Are you going to pass or fail this exam? Well, based on past people and how many hours they study, I can predict that. And here's a decision tree. We looked at that. Why do I do, or we looked at that with the court cases where I can calculate the odds of whether somebody, in this case, is going to hit an oil well and strike it rich. And I can calculate that, or probably more used though as a random forest. Predict these decision trees. But now if several of them are 1, don't give me 1 0 1 0 1 0. Give me a 1. Smooth it out for me. So instead of this very wavy line, a random forest will smooth that decision tree out for me to see where the data is falling. And then one you probably heard of a lot, obviously, is a neural network to do image classification. You know, if I can classify images, well, I could build an autonomous car. Don't hit these objects. I can do it with handwriting as well and things like that. Oh, sorry about that. Went the wrong way. It emulates the mind, but basically what it's doing is looking at images, other edges, object parts, and then objects at different layers of this. They adjust the various weighting and biases so you make sure you're getting what you're trying to get. And then they do a few other things. But notice the math goes back to 1952. But it's really just one equation. Now, you could set all this up yourself, or you could say, hey, look for these features and then set it up. Or you could do deep learning now, which says, figure out the features and then classify them. And then tell me if it's a car or not a car, a neural network. There's also a classifier support vector machine. As I showed earlier, we're separating good and bad customers by something. There's also explicit semantic analysis. We'll look at the string of words, and we see this in large language models like ChatGPT, and I'll talk about that a little bit later. I want to look at the relatedness and build vectors. So classification, lots of different types of algorithms that apply to lots of different types of problems. And the better you know them, the better you'll do them. How about clustering? Cluster things into groups. I want to cluster this into 3 groups. It does it by distance over a certain amount of iterations. That's a k-means, or an O cluster. Oracle built this. It said, do density based. I want voters are more dense in certain areas than others. So there's different types of clustering. There's anomaly detection. Is this the business problem you're trying to solve? Do we have people doing fraud? Or is it more like a time series where people are buying seasonally over Christmas, or they're buying an Airbnb when there's an event? Or is it more like the stock market where it's all over the place and I need to shrink it down by doing exponential smoothing, taking that black line to a red line, or double exponential to the blue line to smooth it out? Maybe even the older data is weighted lower. You can set those in the settings. Where's my problem regression? Most people think of it as a straight line and, sales are going up. Well, the coefficient of determination, or how close those points are, matter a lot. But what if your model the line looks like this? I need something like generalized linear model. Well, it's almost a line. That's a nice algorithm to have. Or do I need an algorithm that does more sine wave or a cosine wave? So the types of regression matter a lot on which algorithm you're using. So these are the functions: classifying data, clustering it, regression.
Rich, if you're still there, I think the sound has cut out or we've lost you. All right, I think we've lost Rich, but I will work on getting him back up, so hold tight. Hey, Rich, just make sure to unmute yourself. And I think we're ready to
You can hear me now?
go. Yes,
And can you tell me, was it the previous slide?
I think previous slide. What's the previous slide? I feel like it
Did
was
you hear about eigenvectors?
I
Flipping
feel
the
like you were on
coin?
an Oracle heavy. Oh, right here, this one.
Right here. Okay. So first of all, sorry about that. My technology has failed me, just booted me out. I don't know why. So am I trying to classify customers? Am I trying to cluster data in some way? Am I trying to look at different types of regression? Am I looking at different attributes that are important? Is it a minimum descriptor length? Is this the algorithm I need? Finding the minimum. We saw in the earlier example where bank funds were very important. So the key items might just be bank funds, and we don't worry about the other ones to make that run faster. Also, maybe looking at principal component analysis, looking at the most important features, and this is maybe 1,000 different values that are in a matrix. Maybe it's how often they buy, how much they buy. Is it highly profitable stuff? Do they recommend other people? And then what happens is we use some math to say, find the eigenvector of that customer. Then go find my eigen customer from big data that looks just like that one. And the eigenvalue could be bigger or smaller, might be a different customer. Or maybe I'm looking at the NBA and I'm looking at shooters and I just want to know the difference between one and the other. And there's a measurement of surprise. In this case, it would be losses if you're going to the guy on the left. And there's also association rules. What are people buying together? Is that your problem? Maybe you can use chatbots to let them know there's other things. Maybe you can move things in the store. And then there's feature extraction. It's more like an eigen face. Or am I looking at dogs and cats or different items This looks at just the principal components of something to make it faster. And then a lot of these algorithms will use something called singular value decomposition to take the matrix of maybe values that are important and kind of shrink them into the least common denominator in a way. And then with Oracle, I have many statistical functions. I have SQL analytics. I could roll things up with different views for different people. And notice I could put those in memory. Isn't that nice? I can put them in different partitions. They have many statistical functions over the decades. But the first thing that started this acceleration is machine learning. If you want to get good at it, the thing you have to know is SQL, PL SQL, or Python, or R. And you have to get to the business side. What's the problem? What's the function I want to perform here on the right? And then trying different algorithms that apply well. And this is just another example. I'm not going to go through that, but I did want to show you what data scientists look for. They look at a ROC curve, which tells them, oh, on the far left here, with 10% of the data, wow, I could see over 60% of the answer. That algorithm is the best one using a ROC curve. Now they'll also use it with a lift curve, and they'll say, oh, this algorithm, GLM right here is, 5.4 times better when I have very little data. And you often have very little data. Or with 10% of the data, I see 40% of the answer. This is using cumulative gain. Or you could put it in numbers. How much money how much revenue are we going to get based on that? But I think you have enough time for machine learning as long as you understand SQL, as long as you understand PL SQL. If you don't understand those, as long as you understand Python. But Oracle went one step further. They said, we'll give you auto machine learning. I wrote a notebook, took a few days. Then I said, well, let me try it in auto machine learning. I'm going to look at customers, see this affinity card again, look at various algorithms, compare them. And Oracle quickly found the one that I found. And I was able to create the notebook, and it built it in Python. In this case, I want to show you a Python example. You usually have %SQL for SQL. But it did it in 4 minutes. So how fast can Oracle build a notebook for me for the problem I have? Very, very fast. But what really helps Oracle is they also have all these values inside the Exadata. Use an autonomous database, you're on Exadata. How great is that? It could be multi-tenant, available, recoverable, could be in memory, all different ways. When I look at Oracle, there's a lot of new algorithms that came out. XGBoost, if you're familiar with Kaggle, won a Kaggle competition. Oracle put it in 21C. It's obviously there. They've added many new ones in 23C. They've also, if you look at algorithms that are used, somebody just scanned all the papers and said, people are talking a lot about support vector machines. Well, we did it for anomaly detection, neural networks, probably image classification. They didn't know what it was for. They just knew they're talking about them. But what are you trying to do? Supervised learning means you have data. Am I looking for fraud? Or am I classifying images? I want to build an autonomous car and not hit light poles and cats and dogs and people for sure, other cars. Am I trying to look at the future and do regression? That's very difficult. There's different algorithms we saw. Or don't I have some data? I just want to cluster data into age groups because I know they matter. I remember in a Twilight Zone was Agnes with Love to do dating. I like this new one. Hey Siri, why don't my relationships work out? This is Alexa. Yeah, maybe that's why. Number one job was AI machine specialist. Number one language is Python. Notebook's not far behind though. SQL not far behind. Oracle integrates Python, by the way, just to let you know. So you use Python. Oracle also added an Oracle Analytics Cloud to not only can I visually see stuff with OAC very well, but now I can just say, oh, do clustering. I'll use the k-means algorithm, put it into 5 groups, and just splits that data into 5. Remember, that was distance-based. If I used an O cluster, then it would be density-based. So a fourth way Oracle does it. As I talked about earlier, Oracle also puts it into all of these other products that they already have. And once again, we hit the wrong thing. I apologize for that. So think about that for a moment. But can you do it? It does it several different ways. But now let's see where we're going even faster now. Steve Wozniak, will we be pets, mere ants to be squashed by our robot overlords? You know, if I look back at, what stare is, an ant on an intelligence, you could say maybe stare 10, and maybe a cat is on stare 50, or a dog is, similar. And then you go up and you say, what stare is a person on? Well, maybe stare 10,000 or 1,000. Let's put it at 1,000. All the people in a city maybe stare 10,000. What is AI at? AI might move to stare, 100 trillion. Man, stare 100 trillion when the AI looks back. The ant, the cat, the dog, I see them down there because I'm an AI, I have great vision. They all look like they're kind of on the same stare with the person who's on stare 1,000. And that's why people are worried about robots. Robots we grew up with, robots maybe a little closer to the future, or some of them, but the actual robots generally try to emulate people in some way. I think we saw in Living Doll, the doll that was becoming a robot. Well, guess what? Many of them are robots. They're out there. Mirror Image talked about somebody was trying to take your place. This guy has his robot actually does his lecture for him. He has built a robot that will do his lecture for him. These robots are getting quite impressive from how they look as well. This guy sold his face to be an announcer on any station that wants it for a certain price. Then here's somebody, and they did this with generative, something called GANs, generative adversarial network. It's a kind of generative AI. It's not like ChatGPT, it's images. They said, hey, if different people in history were walking around like Marie Antoinette or Henry VIII, or how would they look? But one step further is, in Twilight Zone, they talked about this age where everybody wanted to look perfect. Are we already there? He said, consider it's the year 2020. Are we leveraging robots in our businesses? Are you leveraging them? They're available now. Oracle Virtual Assistant works with all these different robotics, and also with Pepper the robot, of course, through something that will take you all of a day or two to learn at the most. Probably an hour, you'll have key parts of it. But robots are here now. I mean, our kids are playing with those robots currently, very similar to the Lonely, where they gave them a robot to keep them company. I think the future is maybe a little scarier when I look at it. The Twilight Zone that's not here yet. 5 people in search of an exit. They have games like this where you're stuck in something. And with virtual reality, how close will it feel like you're in that? Or a guy who didn't know reality from the world he's in. Very similar to the movie Inception, where they said, do they come here to go to sleep? And he said, no, they come here to wake up. They want to live in this other world. Is that the metaverse coming? I mean, right now during COVID, you could use virtual reality or mixed reality for people to see things, or augmented reality to buy items in the virtual world, or beginning of that metaverse. There's also a Twilight Zone at Elegy where everybody seems dead. I have a movie called The Archive. I think that one's very good, but we're moving a little closer to that. I mean, during COVID, the virtual, people are now having, in Japan anyway, where pets actually have funerals and things like that. And Black Mirror is looking for volunteers to create this immortal AI, very similar to Elegy, just to let you know. In his image, where a guy built a robot and the robot didn't believe he was a robot. It's a company called Eter9. the most daring experiment. I think it's over 100,000 waiting list now. And they will make a copy of you so they could do your job for you. Yes, it's time for workers to worry about AI. And you can see all the things that are starting to come together. Robotics, deep learning, machine learning, all the different algorithms you saw, text generation, the after hours. This was a mannequin. She didn't know what she was. Sophia Robot. She's a citizen, wants to get a degree. They interviewed her. She says she wants to have kids. When is she alive? How do we know that whether they have sentience or not? Sentience, I see a sunset and I feel something. Well, a robot can say they do, whether they don't or not. What are the ethical issues that are coming? I don't know, but guess what? They're here. Future of unplanned technology. This guy's arm is his job. If he decided to be a barber, he'd be Edward Scissorhands. Then the connection to the brain. They've been working on this for 50 plus years. When I was in college, I know they were working on it and they put it all into ones and zeros. Well, guess what? Now we can plug into that brain as well. Walking distance, where the guy goes back into his own past. Well, guess what? Somebody's built their own thing where they said, hey, if you wear this headset all the time, now you could just go back in time and see it again in your own virtual reality that goes back in time to any place you want to go. Is it already here? A nice place to visit. That wasn't a good place. I'll tell you that much, but they have right now virtual reality games that are beyond scary. Leverage a database and robots. They have insects that can go take a blood sample, make sure it's the right guy. And the fifth trumpet said the thorax is like breastplates of iron and the sound of their wings like was the roar of many horror. I look at this in Revelations and go, are we getting close to that? If you believe in that, I do. That it may. If you believe there is a God, why did he build this exponential acceleration at this time? Third planet from the sun. You can see they invented Pac-Man even back then. Look at that. Elon Musk already talking about it. Now I need to leave this planet. So the Twilight Zone, maybe it's not here yet, but people have already started building those other things. And then some of the other scary aspects of it, though, are what about all this corruption? It started with viruses, then device takeover, then data extortion, corruption. They said it was going to happen in 2028. Well, that came sooner. Even started with augmentation. They'll turn off your pacemaker, maybe, if you don't pay so much in Bitcoin. And then how did we go from magical to manic to toxic in some way? And can your company build magical? And how important is security now that we've got into this very tougher world? 23C in database SQL firewall blocks, unauthorized SQL and SQL injection attacks with the database as a default. We're moving though from this computer interface, the digital twin who, may help you. It's your autonomous database. In 2020, notice machine learning was not even down here. It's 5% of the people are using it. Here is just a lot of hype. People are tired of the hype. 5% of the people are using it. So 2020, not even 5% were using machine learning yet. Why is this happening? Because when I go from 2 to the 4th, 2 times 2 times 2 times 2 equals 16, directly addressed in memory. And think of Windows 64K, went to 32-bit, went to 4 gig. It was fast. It was huge. Now we're moving to 64-bit. You're going to see some serious stuff. What comes after this? That's going to be quantum. Will there be ways of going through wormholes and things like that? Einstein called quantum entanglement spooky action from a distance, but we're using it in quantum computers. This one on the right is D-Wave. One on the left is the one Google just put out, their latest quantum computer. They move things from 47 years to 6 seconds, 241 million times faster than their one in from 2019. So this is also coming. What does this mean? Well, if I take Nerf balls and I shoot them through one slit or two, this is the pattern I get. But if I do water, it goes like this. Well, electrons should be like Nerf balls, and it wasn't. Why is that? Well, let's look at it closer and see. Well, if I look at it, it only becomes two. So anything watched all of a sudden collapses the state. Look up Schrodinger's cat for that. But what's happening is sometimes electron goes through one slit, sometimes one electron goes through two, or they can split it, and those two are entangled at that point. Sometimes they go through neither. It's just something that works. They had a Solvay conference in 1927 to work on this. Is how long it's been going together. They bring stuff together, they entangle things, and when you pull them apart a galaxy away, they stay entangled. If I happen to look at one and it's red, the other one will be white. So if one spin up, the other one will be spin down. And Schrodinger didn't like this. He hated it. He's like, I wish this was never invented. You can see Madame Curie and Einstein. Einstein called it spooky action from a distance. If I do that and I bring a green one together, a galaxy away, and entangle that, the other one automatically becomes entangled. If I look at it at the right time, the green can move to here. What did I just do? I built a backup that could be a galaxy away and have it instantaneously move the data. So teleportation of at least data, I think is definitely possible. I don't have time to do it, but if you do, throw me a few shares. But basically, quantum entanglement means I could try all the paths, but only one of them works. And you could see how people were quite frustrated with it. If quantum theory is correct, it signifies the end of physics as a science. Guess what? It was correct. Now we're moving to this age of entangledness. This is a great book that talks about it's this God effect. You know, it's like, are your prayers answered because you're entangled with the other side in some way? That's why you feel things, you know, right and wrong, maybe. Final thoughts, not really, but those who think the world become attached to it, well, it's passing away. Never has this been so true than now. Star Trek used to look advanced. Now everything in Star Trek has been invented or is in the process of being completed. Microsoft's still working on the holodeck. You could see some of the other things that people have built over the years. But we're now moving from this using to wearing to implanting the hive mind with Neuralink. You'll integrate to that technology as well. How fast is this going? And how fast are we to the where humans in some degrees transcend biology? And what's the next phase? Generative AI, things like ChatGPT. And then beyond that, foundation models, maybe that include things like generative AI or a large language model like ChatGPT is in this. So here, I'll put it here. ChatGPT is this large language model. So it's a model that I built on language. Just one thing. Think of all the algorithms that were out there and all the things we can do. ChatGPT is just doing one of them today. But they push this foundation model where they say we're going to put all those together. Now let's look at ChatGPT out in November 30th, 2022, almost December of just last year. ChatGPT 4 just came out 3/14/2023. They also do it for images. We can do images as well. It'll also do coding for you, although that's a little more expensive if you buy that. What are the top 10 databases? I tried it on ChatGPT, and here are the results. I'll give you just a second. They're going to be slightly different because I went over to Bard and I asked the same question. And those were the answers. I thought Bard was actually more consistent when I looked at it, and it's up to date. But these things, I'm just going to go back for a minute. ChatGPT sent Google stock tumbling. What happened there? Well, the first thing is Google is the one who came out with the paper that they used something called transformers, where I used to do one thing and now I'm doing a little bit different. So neural networks that include encoder and decoder models, connect those together through an attention mechanism. So it's looking similar to we're doing minimum descriptor length or principal components, but it looks at certain things and it puts a side-by-side way of transforming things and feeding it back into itself. Now, it would take me another, I don't know, 6 months to tell you. These are all the papers, but a lot of Google people put this out, and guess what happened? ChatGPT came up. They wanted Bard to come up first. So GPT, generative, pre-trained, transformer, the paper is. And it's a foundation model itself. ChatGPT itself is a foundation model on large languages, not the only generative AI. You notice we saw earlier where we turned Marie Antoinette, and what should you look at today? That's generative AI that does generative adversarial networks, a different one that somebody else did. But you could see how fast they've gone. GPT-3, 175 billion parameters now, compared to GPT 1.5 billion. GPT-4, 1 trillion parameters now. Wow. And I can do things like deep fake with video. But what's after that? What's after GPT? Okay, you know what? Foundation models. I'm going to get a bunch of tasks. Oh, it only took 113 authors, 215 pages. 50 of the pages, I think, are references, if I'm not mistaken. But now I'm saying, take all those things I was just showing you. Oh, sentiment analysis, maybe regression, all these different things you're doing and all those algorithms, put them into one foundation model. I'm moving from machine learning. Deep learning was really a kind of machine learning. And then foundation models, put it into one place. So machine learning, they're powered by machine learning. Deep neural networks, maybe could do an autonomous car. It's trained though, just looking at images, but it's kind of neural network. It's part of machine learning. The foundation models, transfer learning, where I'm learning from one task to the other from each other when I put it in this foundation model. So now I'm going to learn using something called transfer learning. So instead of many models of all the ones I just showed you, all these different algorithms and things, a model is just the task I want to do. I want to look at an image, or I want to cluster data, or I want to look at good and bad customers. Well, take all those. Maybe the business of the future is just going to have one foundation model where these share information with each other. And this is the Stanford paper. When did that come out? Let's see, let me go back. 21-22, but it's gotten very popular now, more popular than ChatGPT even. And then there's some examples here if you download the paper as well. I'll give you one more though, if you thought that wasn't enough. What happened just on July 5th? Came out with something called Scaling Transformers Now to a Billion Tokens. What is a billion tokens? Well, tokens are a way, so if, let's say I buy ChatGPT, it'll sell me so many tokens, words, word groups. It's how I pay for stuff, but now it's up to a billion that I can do. And you could see just on this graph, 2018-19, transformers, and then all of a sudden 2023, around now, look at the jump. This is not a small jump. Look at how big this was. So it went from, 64, 12, whatever, a million, then a billion all of a sudden. That's what's happening now. And then on the Oracle side, they're getting into the hardware side in conjunction with NVIDIA. I can give you 32,000 GPUs, just one. You could do 2 terabytes and 64 petabytes per second with 32,000 of them. So now you're in the petabytes, almost exabytes. Oracle also gives you all kinds of built-in AI here with large language models that they have. And now they've teamed up with Cohere to do a generative AI service. And I have talked to them, and I wasn't allowed to say anything about it, just to let you know. So where are we going next? We're going to use this generative AI and quantum computers and things to build this future, which, where are you right now? Well, computer as smart as a human across the board. Yeah, you're definitely past that. but eventually you're going to get to this super intelligence. AGI really came just recently. You're kind of in the leading edges of the next phase. I did want to add at least this. The younger generation looks at things like Black Mirror versus Star Trek, where I think it's a little more dystopian. That things like Hated in the Nation, Nosedive, Metalhead, which is a robot dog, was very similar to this one, where somebody died and they be right back and we're just going to make a new one of that person, similar to Eterni. Some of this is already here today. Something about machines, though, I thought told us that people are still very frustrated with them. So the more you can do to make it easier, the better they'll go. So what did we talk about? You've really just entered the Twilight Zone, whether you know it or not. And we saw some of the things that you see now and some of the things that are coming very fast. And then a little bit faster with the things like ChatGPT and foundation models that are coming next. But things will come to those who wait, but only if you hustle. I thought the other genius of Rod Serling is look at all the great actors that he found for these sets. I mean, he literally has the best of the best of the best in many of these episodes. So now let's look at where you are now. And I think Oracle is very well positioned for this. And a little bit more on those. I'll leave this slide up. But now it's 2023, and here you are. Our hero returns from seeing Rich's talk at that fountain of knowledge known as the New York Oracle User Group. And instead of being overwhelmed by all this technology that steal away all their time, our hero now knows all they need to know is things like SQL or Python and things like that to start turning their business, their unique business, to leverage those algorithms that are out there and be prepared for things like robotics and be prepared to mold a better future. And hopefully I've tucked a little knowledge in your pocket so that you have a good feeling of where you are in history and what the options are. And with that, I leave you from the Twilight Zone. I see people say do a TED Talk. If they ever ask me, I don't think they take a talk that's this long. Any other questions before we go? I want to thank everybody for coming, that's for sure. You can certainly put any questions in. But I think leverage your skills, whatever you do. Leverage machine learning. I do think that we are probably the last unaltered generation of humans are walking the earth today. And in the future, we're going to have people that are augmented with many, many different things. I remember Pope Benedict once saying, when people feel they can create custom human beings, you're really building a robot and you're going to find you lost something that was very dear to you if you're not careful. So I think we have to be very careful with how we do it. And some of the great people from NYOUG are key to get into this new world and not spend too much time in yesterday. But you're in a town called yesterday currently. And in 10 years, you won't be able to see this town in the future. It'll be past. I want to thank everybody for coming and have a great day.
Thank you so much, Rich. It's always such a pleasure to have you talk to all of us. So if you guys have any other questions for Rich, please drop them in the Q&A. Otherwise, be on the lookout for an email from NYOUG or from Viscosity on how you can find the recording from today, as well as a slide deck. And then if you have any other questions at that time, you can just respond to either of our emails from NYOUG or myself. But with that, thank you guys so much. I hope you guys register for more of our upcoming events. NYOUG and Viscosity have added several more webinars to our calendars just as of the end of last week. So go check them out if you haven't. And Rich, thank you so much again. We hope to see you soon.
Thank you for having me. Sorry for the glitch. My robot, he went offline there and I had to pull it back online and take over for him. So great to
You
be
know what?
here.
It's okay. It's how we know you're not a machine or some kind of artificial,
There you
you
go.
know, mistakes should be made.
All right.
Yeah, thank you very much, Rich.
Thank you guys so
Thanks
much. And
for
thank
having
you,
me.
NYOUG.
Yeah. Thanks,
Coleman
Coleman,
as
too.
well.
Thanks, Rob. Thanks,
Okay.
Monica.
Yes,
And
of
have a
course.
great day.
Y'all take care.
All right.
Mhm.